Hello friends, I am Arem Guru, working as Assistant Professor in Shiro Technology College of India. So this is module number 4. I welcome you in this module, namely Planimeter and study of digital planimeter. So there are different ways of computation of area. The term area in the context of surveying refers to area of tract of land projected upon the horizontal plane and not to the actual area of land surface. Area may be expressed in the following units. It is expressed in square meter, it is expressed in hectares, it is expressed in square feet and expressed in acres. The following is a hierarchical representation of various methods of computation of area. So area can be computed by graphical method, area can be computed by instrumental method. When you consider the graphical method, in the graphical method again there are two methods, namely from field nodes and from plotted plan. So generally from field nodes, we are having the measurements such as chainage and offset, and when we are trying to prepare the sketch of given area by making use of chainage and offset, then it is possible to find out the area of any track. Similarly, there is another method, namely from plotted plan. So in the plotted plan there are again two methods, that is entire plan and boundary area. So the boundary area method has been divided into four parts, that is mid-ordinate rule, average ordinate rule, trapezoidal rule and Simpson rule. So these are the different type of rules. By making use of these rules, it is possible to calculate the area on the paper. Similarly, it is possible that by making use of instrument like planimeter, whenever we try to calculate the area, then the method is known as instrumental method. Then in the computation of area from field nodes, this is done by two ways. In step 1, in the cross-top survey, the area of field can be directly calculated from field nodes. During survey work, the whole area is divided into some geometrical figures such as triangles, rectangles, squares and trapeziums, and then the area is calculated by making addition of all the areas. Then area by planimeter. Area by planimeter. A planimeter is a mechanical device that you can use to compute the area of an irregular figure after tracing the perimeter of a figure of a scale drawing of the figure with the tracing point on the planimeter. The most commonly used instrument is called polar planimeter. Again, the instruments are of different types. So the types of planimeters are ancillary polar planimeter, radial planimeter and digital planimeter. So the digital planimeter, in which the area obtained by planimeter is more accurate than obtained by graphical method. It gives more accurate results within 1%. Then instrumental method. The instrument used for computation of area from a plotted map is the planimeter. The area obtained by planimeter is more accurate than obtained by graphical method. There are various types of planimeter in use, but the ancillary polar planimeter is the most commonly used. The construction details of planimeters are shown in the figure. The different part of the planimeter are anchor arm, then tracing arm, anchor point, tracing point, then measuring wheel, vernier scale, index mark, carriage, counting disc, tracing point, adjustable support, fulcrum point and pivot point. So these are all parts of the instrument. The planimeter consists of two arms. The arms A is known as tracing arm. Its length can be adjusted and it is graduated. The tracing arm carries a tracing point D, which is moved along the boundary line of the area. There is an adjustable support E, which always keeps the tracing point just clear of the surface. The other arm F is known as pole arm or anchor arm and carries a needle pointed weight of or fulcrum K at one end. The weight forms the center of rotation. The other end of the pole arm can be pivoted at a point P by a ball and socket arrangement. There is a carriage B, which can be set at various points of the tracing arm with respect to vernier of the index mark I, as shown in the figure. Then the carriage consists of a measuring wheel W and vernier wheel. The wheel is divided into 100 divisions and the vernier into 10 divisions. The wheel and the vernier measure reading up to 3 places of decimal, that is 0.125 or 0.174, etc. The wheel is geared to a counting disc which is graduated into 10 divisions. For 10 complete revolutions of the wheel, the disc shows a reading of 1 division. Thus the planimeter shows a reading of 4 digits, that is 1.125, 1.175, etc. The counting disc shows the units. The wheel shows tenth and hundredth, and vernier shows thousandths unit. The planimeter rests on the tracing point, anchor point, and periphery of the wheel. Then in the computation of area from field notes, this is done by 2 ways. In step 1, in the cross-tab survey, the area of field can be directly calculated from field notes. During survey work, the whole area is divided into some geometrical figures such as triangles, rectangles, squares, and trapeziums, and then the area is calculated by making addition of all the areas. This is the image of Amsler planimeter on which the anchor arm, pivot point, tracing arm, wheel, graduated disc, roller, and the pivot point is shown. Then instrumental method. The instrument used for computation of area from a plotted map is the planimeter. The area obtained by planimeter is more accurate than obtained by graphical method. There are various types of planimeter in use, but the Amsler polar planimeter is the most commonly used. The construction details of planimeters are shown in the figure. The different parts of the planimeter are anchor arm, then tracing arm, anchor point, tracing point, then measuring wheel, vernier scale, index mark, carriage, counting disc, tracing point, adjustable support. But it is always preferable to set the anchor point outside the figure. If the area is very large, it can be divided into number of sections. A good starting point is marked on the boundary line. A good starting point is one at which the measuring wheel is dead. That is a point where the wheel does not revolve even for a small movement of tracing point. By observing the disc, wheel, and vernier, the initial reading IR is recorded. The tracing point is moved gently in a clockwise direction along the boundary of the area. The number of times the 0 mark of the dial passes the index mark in a clockwise or anti-clockwise direction should be observed. Finally, by observing the disc, wheel, and vernier, the final reading FR is recorded. Then the area figure may be obtained from the following expression, that is, area A equal to M multiplied by FR minus IR plus or minus 10N plus C, where M is the multiplier given in the table supplied by the manufacturer, and N is the number of times the 0 mark of the dial passes the index mark. C is the constant given in the table. FR is the final reading and IR is the initial reading. So N is considered to be positive when the 0 of the dial passes the index mark in a clockwise direction, and N is considered negative when the 0 of the dial passes the index mark in anti-clockwise direction. The value of C is added only when the anchor point is inside the figure. Then zero circle of the planimeter. In this slide we are going to see zero circle of the planimeter. When the tracing point is moved along a circle without rotation of the wheel, that is when the wheel slides without any change in reading, the circle is known as zero circle or circle of correction. The zero circle is obtained by moving the tracing point in such a way that the tracing arm makes an angle of 90 degree with the anchor arm, as shown in the figure 7.16. So T is the tracing point and A is the anchor point and W is the position of wheel and R is the radius of zero circle, and zero circle is shown with a dotted and paper is shown on the figure. When the anchor point is inside the figure, the area of zero circle is added to the area computed by planimeter. The anchor point A is the center of rotation and at R dash is known as radius of zero circle. For finding the radius of zero circle, we are supposed to consider the different cases. Then in the computation of area from field nodes, this is done by two ways. In step 1, in the cross-tab survey, the area of field can be directly calculated from field nodes. During survey work, the whole area is divided into some geometrical figures such as triangles, rectangles, squares and trapeziums, and then the area is calculated by making addition of all the areas. Then when the field is inside the pivot point, then let TP equal to L and PW equal to L1, AP equal to R and AT equal to R1 and angle AWT equal to 90 degree. From right angle triangle AWT, AT square equal to TW square plus AW square. Since TW square equal to TP minus PW square plus AW square equal to AP square minus PW square as per the figure 7.18. Then R1 square equal to L minus L1 bracket square plus R square minus L1 bracket square. Therefore R1 we can get as under root of L square minus 2 times L1 plus R square, where L is the distance between the TP, that is the tracing point and pivot point, and L1 is the distance between pivot point and wheel, and R is the distance between tracing point and anchor point. So area of zero circle is given by pi r dash square. So when the wheel is placed beyond the pivot point, then area of zero circle can be calculated as A equal to pi into r dash square, where we can substitute r dash equal to L square plus 2 times LL1 plus R square. So where R dash equal to under root of L square plus 2 times LL1 plus R square. Hello friends, I am RM Guru, working as assistant professor in Shiro Institute of Technology, College of Mumbai. So this is module number 4. I welcome you in this module, namely Planimeter and study of digital planimeter. Similarly, we can calculate the area of zero circle by knowing the value of multiply constant as well as instrument constant, that is A equal to m into c, where m is multiplier value given in the table and c is the constant given in the table. Similarly, we can calculate the area of zero circle by planimeter. In this, geometrical figure is considered whose area is known. After this area of figure is computed by planimeter, then the area of zero circle equal to actual area minus area computed by planimeter. Points to be remembered while using the planimeter are: the map must be placed over a horizontal plane. Secondly, the anchor point should preferably be kept outside the figure to avoid additive constant. Thirdly, the area of figure should be measured twice from different starting points. If the area is large, it should be divided into number of sections. The area of each section may be calculated separately by taking outside poles and then added to obtain the total area. The initial reading may be set to 0 for sake of simplicity. The tracing point should be moved gently and exactly along the boundary line. The map should not be folded. The surface of map should be smooth. So these are the care we are supposed to take while using the planimeter. Then we will see one of the problem on planimeter. I will read the problem. The following readings were recorded by a planimeter with the anchor point inside the figure, where value of initial reading, that is equal to 9.377 and FR equal to 3.336 and M multiplier value equal to 100 cm square and instrument constant C equal to 23.521. Calculate the area of figure when it is observed that 0 of the dial pass the index mark once in anti-clockwise direction, that is to say that the value of n equal to -1. So given IR equal to 9.377, FR equal to 3.336, n equal to -1, m equal to 100 cm square and the instrument constant C equal to 23.521. Then from the expression A equal to m multiplied by FR minus IR plus or minus 10n plus C, we can substitute the values of all the parameters. We get A equal to 748 cm square. So this is again the unslab planimeter. So generally whenever we are taking the reading, we are supposed to see this particular index, and depending upon the position where it is going to lie, we are supposed to pick up the lowest value, and since it is lying in between 9 and 0, then we are going to pick up the reading as 9. Then we are considering this particular roller, and corresponding to 0 of the vernier, we are trying to pick up the 2 digits from this particular roller, that is 5 and 5.5. So 9, 5, 5, and then we are going to consider which line is going to coincide with the main scale of the roller from the vernier. Suppose it is say 5, then the reading will be 9.555. Then we will try to solve another problem for calculation of area of zero circle with the following data, where IR is 7.775, FR is 4.825 and the position of anchor point is outside the figure, and in the remark the 0 crosses the index mark once clockwise, that is to say that value of n equal to +1. And for the second case, the initial reading is 2.325, final reading is 8.755 and the position of anchor point is inside the figure, and in the remark the 0 crosses the index mark twice anti-clockwise, that is to say that n equal to -2 for second case. So in first case n equal to 1, C equal to 0 as the anchor point is outside the figure, and m equal to 100. So area of figure equal to m multiplied by FR minus IR plus or minus 10n plus C, that is 0. So therefore we can substitute the value of m, FR, IR and n to get the area of zero circle, that is 705 cm square. Then we will consider case number 2, where the value of multiplying constant m equal to 100 and the number of times 0 crosses the index, it is -2 since it is cross 0 in anti-clockwise direction. So and C equal to, we have to find out. So area of zero circle is given by m equal to A equal to m multiplied by FR minus IR plus or minus 10n plus C. So we can substitute the value of m, n and C to get the value of, but area of zero circle is given by 100 minus 13.57 plus C. So this is area equation number 2. So equating 1 and 2, we get C equal to 20.62 and area of zero circle equal to M into C. Therefore 100 multiplied by 20.62, it is 2062 centimeter square. Then instrumental method. The instrument used for computation of area from a plotted map is the planimeter. The area obtained by planimeter is more accurate than obtained by graphical method. There are various types of planimeter in use.